This video is going to focus on Standard 4OA3, solving multi-step word problems. There are a variety of examples to showcase different types of strategies and problems, such as estimation strategies, how to solve when there are multiple operations, and how to solve when there is a remainder. This is our first example. On a vacation, your family travels 267 miles on the first day, 194 miles on the second day, and 34 miles on the third day. How many miles did they travel total? We are going to focus on using estimation strategies with this multi-step problem. There are a few ways we can look at this. Looking at our problem, we are trying to solve how many miles did they travel total. We know that they traveled 267 miles on the first day, 194 miles on the second day, and 34 miles on the third day. First, rounding 267 miles to 300 miles. Second, we can round 194 miles to about 200 miles. Lastly, we can round 34 miles to about 30 miles. Adding all of these up, we can get an estimation of about 530 miles total that they traveled over the 3 days. A second way to look at this problem still involves finding how many miles they traveled total, but looking at it, we can add 267 miles and 34 miles, thinking that 267 is about 270 and 34 miles is about 30, which together makes about 300 miles. Next, we have to add in our 194 miles, which we can round to about 200 miles. Together, adding the 300 miles from the first two numbers and the 200 miles from the second number, we get an estimation of about 500 miles total that they traveled. For our last option, we are once again solving for how many miles they traveled total. First, looking at 194 miles, we will round this to 200 miles. Second, looking at 267 miles that they traveled on the first day, we know we can break this up into 200 plus 67. Taking our 200 and adding it to our estimation from the first number, we get about 400 miles. However, we still have the leftover 67, so we'll drag that down here. We have the 67 miles plus the last 34 miles they traveled on the third day, which we know together equals about 100 miles. Adding together our 400 miles and our 100 miles gives us an estimation of a total of about 500 miles. Our second problem is an example of a problem involving multiple operations. This problem says, your class is collecting bottled water for a service project. The goal is to collect 300 bottles of water. On the first day, Max brings in 3 packs with 6 bottles in each container. Sarah wheels in 6 packs with 6 bottles in each container. About how many bottles of water still need to be collected? In this multi-step problem, we have 2 steps to think about. The overall question is asking about how many bottles of water still need to be collected. However, we know that the goal is to collect 300 bottles. So first, we must find out how many bottles of water we already have before we can find out how many bottles we still need. We know that Max brought in 3 packs with 6 bottles in each container. Sarah brought in 6 packs with 6 bottles in each container. Using our order of operations, we know we're going to do the multiplication step of this problem first. Therefore, we know that what Max brought in, 3 packs with 6 bottles in each container, multiplies to make 18, whilst what Sarah brought in, 6 packs with 6 bottles of each container, multiplied to get 36. Adding these two numbers, 18 plus 36, we can estimate that this will be around 50 bottles that we have already collected. Therefore, using a counting up strategy, we know that we already have 50 bottles of water. We know we can use another 50 to get to 100, another 100 to get to 200, and a last 100 to get to 300. 300 is our goal. Therefore, without the 50 bottles we already have, 50 plus 100 plus 100 gives us about 250 more bottles needed. Another way to look at this problem is, again, starting with our multiplication and our order of operations. We know Max brought in 3 packs with 6 bottles, again multiplied to get 18, and Sarah brought in 6 packs with 6 bottles, again multiplied to get 36. Rounding 18 to about 20 and 36 rounded up to 40 bottles, and adding those two together, we know that we have about 60 bottles so far. Therefore, if we know we need 300 bottles total and we have 60, subtracting what we have from what is needed gives us 240 bottles still needed. Our last problem is an example of a multi-step word problem that involves a remainder. This problem says there are 1,128 students going on a field trip. If each bus held 30 students, how many buses are needed? We know the question we're trying to solve is how many buses are needed. The information in the problem tells us that there are 1,128 students total, and each bus holds 30 students. Therefore, dividing the number of students, 1,128, by the number of students that can fit in each bus, 30, will give us the number of buses needed. 1,128 divided by 30 equals 37.6. Since we can't have 0.6 of a bus, we know we will need 37 buses, and with the remainder, since those students still need to attend the field trip, we will need an additional bus. Therefore, we will need 38 total buses.